In today's video, I'm going to be building myself a new home server. But unlike previous server builds I've done where I've built generally sort of NAS type servers, this time I'm building a dedicated VM host. And I'll be doing it using this ASUS RS100 server. The previous server builds I've done have all been generally NAS based, and because I'm trying to build a lot of storage into a short depth machine that can fit into my short depth rack, I've had to go completely custom and build it from scratch. And for quite a while now, I've just been running VMs under TrueNAS, and that's been okay. But I've decided I wanted to build a dedicated VM host running Proxmox to run all my VMs for my home automation and things like that. And because all I need is just a basic 1U server, I don't need to worry about lots of storage bays and things like that. I can actually finally get a pre-built server that is short enough to fit in the rack. Because personally, I much prefer just buying pre-built servers rather than trying to build them, because you're building a fairly space-constrained sort of chassis. The cooling's a bit tricky to figure out. It's just much easier just to get pre-built. And that's what I have here with this ASUS RS100. Now, the ASUS RS100 model goes back many years, so if you're looking them up, you see all different generations going back to like Core 2 Duo type servers that would be basically useless to buy nowadays. But they still make them, and they've evolved that over the years to support newer CPU generations. So this model here, the full model, is the RS100-E10-PI2 or P12, can't quite tell. And this is, I think, one generation old. So this is a Coffee Lake generation machine, so it's not the complete newest thing. The RS100-E11 is out now, but it's only one generation old, so it's still pretty current. And I picked this up on eBay for only £350, which for the spec was a really good deal, because this has a 256 gig NVMe SSD that I'll be upgrading, 16 gigs of DDR4 RAM, and a Xeon E2274G Coffee Lake CPU. Which is pretty current. It's one generation old, but for £350, that is a stupidly good price. In fact, I looked up a similar machine from Broadbury, which is a sort of UK system integrator that build custom servers, and they also offer custom-built RS100s. And they're offering the newer version of this, basically the same spec, with a one generation newer CPU, and that's over £1,300. And that's excluding VAT, so £1,500 plus for the same spec. So that is a super good deal getting this for £350. The person selling it was selling an absolute ton of them, and most of the other ones they were selling were Xeon E3 based CPUs, so a lot older, and they were all around about the same price. So I suspect they just had a batch of them to sell, and they just sold them all off at the Xeon E3 based price, and either not realised or not really cared that this one was a much newer generation, because yeah, that was a stupidly good price. I'll admit I wasn't even in the market for a new server, I just saw the price and kind of bought it and now need to use it, but yeah, it was a really good price. So what we'll do in this video is we'll take a look at the hardware in the server that it came with as stock. And then I've got a few upgrades to put in, so we've got a few different upgrades. We'll talk about these as we go, but yeah, we've got a few little upgrades I'll be putting into this before I set it up. And then what I'll be doing is I'll be installing Proxmox on this, getting it installed in my rack, and this will become my new VM host. So I'll move over all my home automation from the FreeNAS box, or TrueNAS scale, sorry, onto this running under Proxmox. So yeah, that'll be really good. So what we'll do first of all, we'll get all these upgrade parts out of the way, pop it open and see what's inside and see what I got, and then we'll talk about the upgrades I'll be doing. So first off, here at the front of the server, nothing much to write home about, just ASUS logo, lots of ventilation. An optical drive, cool, I won't be using that, but fair enough, it's got one. A couple of USB ports, front VGA, so that'll be actually useful because it's installed in a rack that doesn't have rear access, so if I need to ever plug a monitor in, I can do it from the front. Various LEDs, stuff like that. It's fairly basic. There's no hotspot drive base, which I do like to have on a server, but I'll be running this off of NVMe M.2 drives, so it really doesn't matter not having those. And then taking a look around the back, we have the rear I/O. So we have four gigabit Ethernet ports, some USB-A ports, and I think these are presumably 10 gig because they're that sort of teal colour, and then some regular USB 3 ports. This support for the onboard management controller, which is optional, but we'll be adding that in. Serial port, VGA, power button on the back, some LEDs, little BIOS status readout, just fairly standard stuff, and a regular power supply. So it's a fairly basic server. It's not, dual power supply or anything. It's just a fairly standard ATX board, maybe micro ATX, don't know. Fairly standard sort of desktop board. It's nothing particularly fancy, but it is all still server grade hardware. Then there's one expansion slot we'll be using, and the blank's also missing. And this is kind of interesting because it kind of alludes to what I think this was used for previously. Because I don't know what company I bought this from because it was just a sort of person's personal eBay account, but it was clearly a job lot of servers from a company. And what they were selling was a bunch of these servers and a bunch of Blackmagic, I think, DeckLink capture cards. And given the slot on this is missing, what I suspect this was some sort of video capture streaming type machine. And I suspect they obviously had these servers, and each server would have had one capture card in it, so maybe some sort of like event live streaming, something like that. That's what I suspect this was used for, but yeah, it just came with that card removed, which is absolutely fine because I'll be putting another card in that slot. So what I'm going to do is we'll open this up and take a look inside. It's not toolless or anything, a few screws to take out, but shouldn't be too bad to get inside. Okay, so I've now taken the screws out, let's see what's inside. So let's open this up and take a look at what we have. So this is obviously the completely stock hardware that arrived from the seller, and I'll be doing a few upgrades to it. So as you can see, the machine's actually basically spotless inside. It'll be interesting to check the power on hours of this SSD to see how long it's actually been used for, because it is extremely clean, and generally you can view the power on hours of a SATA SSD or an NVMe SSD, and it should be able to tell you roughly how long it's been used for, assuming it's the original drive. So yeah, it's pretty clean inside, which is good. I don't think it's that old at all. As you can see, we've got two 16 gig sticks of RAM. Seems some sort of like manufacturer part number on there, so I don't know if that would indicate who the actual OEM of this was. Nah, it's just a Samsung stick. Doesn't seem to have a sort of manufacturer. Presumably either custom or from one of those companies like Broadbury or whatever, but yep, that's the RAM there. So two 16 gig sticks. That'll be DDR4, presumably ECC, but it'll be unregistered ECC RAM, which is kind of what these machines would take. Next up over here we can see all the cables that go through. So there's a couple of 3.5-inch hard drive bays that I won't be using for now, but if I did ever say put something like Plex on this, I don't plan on doing it, but if I did, I could stick a couple of 3.5-inch drives in there for bulk storage. And these seem to all be cabled up. There is a SATA cable there, presumably another one sort of sitting around here. So there is cables all in place for putting some wired hard drives in, or 3.5-inch drives in if I needed to. Likewise, there's power cables. The cables are a bit of a mess, but that's kind of what you're going to get on a machine like this. It's a pre-built server, but it's not going to be completely custom with like a 12-volt power supply and boards that break all that out. It is a standard, 1U power supply, and then it splits out to various parts. So that's kind of fairly standard. But yeah, all the cables seem to be in place for the drive. You've got your optical drive there, which I really don't need, but I may as well leave it in because it fills in the space on the front, so fair enough. Other parts over here, obviously CPU's under this heatsink, which is then cooled by these fans. So you've got these 40mm fans in the front that are going to blow air through it and cool that heatsink. And what's nice to see on this is there's also a 40mm fan here for cooling the expansion bay. And there's this sort of like air deflector shield that seems to almost be adjustable with this screw. You could loosen that screw off and move this in and out to direct air over an expansion card. That will actually be quite useful because I'll be putting a 10 gig network card into this that will require active cooling. And generally speaking, those cards, you're going to need to blow air over them. They don't have a fan. There's a heatsink, but there's no fan on the heatsink. They're designed to be installed in high airflow server cases. So it's good to see here that I do have a fan to cool that expansion bay. With a regular desktop PC, or even a lot of time if you self-build a server, you don't have things like this, so it's nice to have that. In terms of other hardware, we've got the included SSD down here, which I think is meant to be 250 gig. So I'll just quickly pop that out and see what it is. Although I don't think it's a particularly good one. I think it's a fairly basic DRAM-less SSD. So we'll pop it out now and see what it is. It's a Samsung PM991. It's a fairly basic OEM drive. I've seen these in many sort of self-built or pre-built machines. It's a relatively basic drive, 256 gig NVMe, but I'm pretty sure it's just like one of those single chip SSDs, so it's not got a DRAM cache or anything. So I'll be upgrading this to a better one. I'll leave it in now just to take a look at the power on hours, just out of curiosity, but we'll be upgrading this to a pair of SSDs that are a kind of redundant configuration. Not that SSDs really need that, they're generally pretty reliable, but I mean, call me old-fashioned, in a server, I always want to have drives in some sort of RAID type configuration, even if they are SSDs. So, yep, that can go in there. And then finally, we've got the riser for the expansion card, so my network card can go into that. It's just a PCI Express riser, so yeah, I can plug the expansion card into that, and that goes into the slot. And there's the model name of the motherboard. It's an ASUS P11C-M/4L. It's a fairly standard ATX type board, maybe micro ATX, kind of a bit tall for micro ATX type board. It's a relatively standard board. It's not a proprietary board for this machine. You could upgrade this if you wanted to, but whatever board you got would have to fit into a 1U form factor, which can be a bit tight for backplates and stuff. But yep, fairly standard board. The final thing of interest inside is this ASpeed AST2500 management controller. And this is a sort of management controller that's used in tons of different servers. And essentially what this does is it acts as the machine's graphics adapter, and it also has a little web server on it, and allows you to access the machine over the network and give you remote KVM. And it's all handled through this chip here. However, what's interesting / annoying with ASUS servers, and ASUS motherboards in particular, is this is kind of like an optional extra. So as standard, this will just work as a graphics adapter, or not even graphics, a very, very basic video adapter. It's very low end. And that's all it'll do out of the box. And there's this little chip that I think is like a RAM chip to kind of back that up. But out of the box, this will not work as a management controller. Instead, to enable this, you need to buy a module from ASUS called the ASMB9. That's the little header for it down there. As far as I'm aware, all that module actually is just the flash memory that stores the firmware for this chip. So without that, it won't work as a management controller, but if you add that chip in, it enables it. This is a little bit annoying given you have to buy it extra, but equally, the software on that is not made by ASUS, it's third-party software, so I suspect that's kind of how they handle the licensing fees. If they bundled that with the motherboard itself, they'd have to pay a license for every motherboard they sell, whereas if they optionally sell the module, they only need to pay a license for each module they sell, so I think that's kind of why they're doing it. Thankfully, those modules are pretty cheap. They're about £30, if not less. So I've picked one up, so we'll be installing that later, so we'll take a look at that. But yeah, so that's where you install that management controller. So out of the box, this won't work with the management controller, but we'll add the module in, and that will enable that. But yeah, other than that, it's a fairly basic machine inside. It's a nice enough little server, very clean, so yeah, it'll be really interesting to see how long it's been powered on for, because it looks basically new. But yeah, time to get this thing sort of put back together, quickly fire it up and see what it does, and then we'll get these upgrades put in. Okay, so I'm going to connect the machine up, so what we'll do is we'll quickly fire it up into Linux, just check it all works, take a look at the specs, and then we'll get the upgrades installed. So we'll put the flash drive in there and boot it up. If you wonder what this device is, this isn't a laptop, this is called a lap dock. I made a video about this previously. So essentially it's a portable monitor, keyboard and touchpad, but in a laptop style form factor, so it just plugs into the server over HDMI to VGA and then USB for the keyboard and mouse, and it means I can use it without having to get a big monitor out. This thing's super useful, so if you're interested in that, definitely check out my other video on it. But if we just fire up the server now, we'll get it booted up. Now, as you can probably hear, maybe, it's not quiet. This machine is pretty loud. Now, I know all 1U servers generally are quite loud, but this is probably one of the loudest 1U servers I've had in a long time. When it ramps up to full speed, it gets really, really loud, and that's fair enough. But I think the problem isn't really that it's loud at full speed, it's that the baseline speed is still pretty high, even when it doesn't really need that level of cooling. Now, I've already done a bit of digging around, tried different things, and unfortunately I can't really set the fan speed to a better level with the sort of default firmware. The BIOS lets you either set it into auto fan mode, where it adjusts based on CPU temperature, or you can set the fan in the BIOS just a single speed. The problem with that is that if I set it to a very, very low speed, that's absolutely fine at idle, and this machine will probably sit at idle most of the time. However, as soon as the machine ramps up and needs that power, it then doesn't ramp the fans up, and the machine gets too hot. And unfortunately, I can't really see a way to adjust the fan curves, even with the management controller, because some stuff says that you can control the fan curves through the management controller, but that doesn't seem to work for me. However, I have found that at least running the fan control package under Linux does allow me to control the fan speeds, and I can get it down to a perfectly quiet enough level, so I'm happy enough to do that. It means it's reliant on the OS, but it's easy enough to set up fan control, and that'll do the job for me. While it would potentially be possible to replace the fans, you're not really going to get fans that are quieter, that are still going to move enough air if the machine needs that. And then the other option I did briefly consider was Noctua's little fan controller. Noctua sell a PWM fan controller that you can wire in line with a fan connection to a motherboard, and it just shifts the PWM speed, so the motherboard can still fan control the fans automatically, but you can just tell it to slow them all down a bit, so it still reuses the motherboard's fan curves, but just all step down a bit. I did briefly consider that, but once I got fan control working, I decided that was fine. So we'll take a look at that later, but here we are in the BIOS, so it's all fairly standard. Intel i2 10X on board, there's the CPU, so a Xeon 2274G Coffee Lake CPU, 16 gigs of RAM, that all looks fine. Come through here, all looks pretty much fine. There's the SSD, Samsung SSD, that's exactly what I expected. So what we'll now do is we'll boot it off this Ventoy flash drive, and then we'll get it going. So yeah, that's a look in the BIOS. What we'll now do is we'll quickly reboot it, and then we'll get it booted up from this flash drive into Linux. Just take a look at that SSD, kind of interested to know what the power on hours are. So we'll get this booted up into Linux, and then we'll take a look. Okay, so here we are now booted up into Linux, and I've just run SmartCTL on the SSD, and as you can see, we've got a power on hours of 1537. So that's pretty low. I mean, it's definitely not a new machine, it has been used, but that only works out to about 64 days, so it's definitely not been continuously running in a data center or whatever for many, many years. So it's probably either not been used heavily, or it's probably, you know, as I was thinking, maybe some sort of video streaming server where it's only being turned on periodically. But to be fair, 64 days of use on a server is not bad. Obviously, I'll be replacing that drive anyway, but it's good to see it's not been, you know, run heavily for years. It's still a pretty new machine. And that probably explains why it's so clean inside as well. So yeah, that's it there. So what we'll now do is we'll get this powered off and take a look at the upgrades we'll be doing. Okay, so in terms of upgrades, I'm not going completely ridiculous, just a few little things. So the first thing I'm going to do is put a pair of new SSDs in. So obviously it's got a 256 gig SSD in it right now, which would probably be fine, but I might, you know, might find it a bit tight. It's only a single SSD as well, and it's not got a DRAM cache. It's a fairly low-end drive. So I've picked these two new SSDs up. These are Sabrent Rocket NVMe drives. They're NVMe PCIe 4.0, which won't be used by this machine, I don't think. But, decently powerful modern drives, terabyte each. These were about £50 each, if that. They weren't that expensive. So picked two of these up, so I'll run these in a kind of mirrored configuration. Be nice to have decent, fast SSD NVMe storage. And this will be the benefit over my current server, because the current server is built for bulk storage. So it is SSD based, but it's using large SATA SSDs, because with that I care more about being able to easily expand it and have a lot of drives rather than performance. Whereas with this, because it's being used as a VM host, I can have super fast NVMe storage. So that'll be really good. So two of those. We'll also be upgrading the network cards. Obviously it's got 4 regular 1 gig NICs. Those would realistically be fine for what I'm doing, but may as well go overkill. So here I have a 10 gig NIC we'll be putting in. This is a HP part. Well, it's from an old HP server, but it's actually an Intel X540 network card. So basically an Intel X540-T2 kind of chip, just rebranded for HP. So that'll be absolutely fine. And these are very cheap nowadays. I think I got this for about £30. Now, this isn't the newest NIC, and it's not going to be the most power efficient. So if you cared about that, you'd want to go for like the Intel X550 network cards. They're a bit newer, a bit more power efficient, so they'll run a bit cooler, especially if you don't have much active cooling. You'd probably want to go for that. And those also support N-base T, so they'll support 2.5 gig and 5 gig. This will only support 1 gig and 10 gig, but it's fine. This is about £30. Those higher end or newer cards are at least 150, so it made sense to get this. So yeah. Now I know that with this I could have gone for SFP Plus ports, and that would have probably been a lot cheaper and potentially a bit more power efficient. However, the network switch this will be connecting to is a 12-port switch. It's a Cisco small business switch. It has 12 10 gig ports. 10 of those are 10 gig base T, and 2 of those are SFP Plus. So I only have 2 SFP Plus ports on that switch. So I could have done this, but I'd rather keep those SFP Plus ports spare for if I'm ever testing something out or setting up new equipment or something that might only support SFP Plus. I'd rather keep those ports spare. Whereas I've already got a ton of 10 gig base T ports that aren't being used. So I can use those with this, and it just keeps those SFP Plus ports free. So that's why I've done that. But yep, that's that there. And then the final upgrade we'll be putting in is that ASMB9 management controller, which is here. And I'm going to do an unboxing of this very quickly, because while unboxing an ASUS management controller seems a bit boring, this is probably the most incredible packaging I've ever seen for this sort of device. Because when it arrived, I was waiting on a particular delivery, so I knew what the delivery was meant to be coming. And when the guy handed it to me, it was like in a plastic bag, and I thought, this cannot be the right thing because it's a big box, and this is a tiny little management controller. So let's take a look at the packaging for this. So we have a big outer ASUS box, of course. That's fair enough. That's our shipping box. So inside here we have a smaller box. So we'll just take a look at this. So here we have the box, and that's definitely the right thing, the ASMB9 iKVM. So we'll open this box up, and we have another box in the box. So here we have a box. There's something rattling around in there, so we'll see what that is. Oh look, it's the management controller. So that is the ASUS ASMB9 management controller. That tiny little thing there, and as you can see on the back, as I suspected, it literally is just a little bit of flash memory for that A-speed chip. So yeah, that's all it is there, and that's the box it came in. But of course, we can cut them some slack. With something like this, they obviously have to provide a lot of instruction manuals in different languages and all the safety paperwork, and that's going to be big. That's going to take up the box. That's why it's such a big box. So under here, we'll find all that clearly. No, we have a bag, and the bag contains 2 stickers. It's got one sticker that tells you helpfully not to put it in the bin, because I needed that to be a sticker, and another one which is this. Now, this is actually probably that license I was talking about, where I was saying that they provide this separately probably to save on licensing costs, because this is from American Megatrends, and it says Mega Rack. Now, Mega Rack is AMI's iKVM software, so I suspect this is the license for the software that's on this flash chip. But yeah, there's no manuals with this. Literally all this packaging for a device that size and 2 stickers, one of which basically tells me not to put it in the bin. Fantastic. That is amazing. I bought this months ago, because this video's been a long time in the works, and I've literally had that box sitting around taking up space for ages, because I just wanted to show that on camera, because that is the most incredibly ridiculous packaging I've ever seen. You see the jokes about Amazon shipping an SD card in a huge box, but I think in terms of scale, that's even worse, or this is even worse. So yeah, that's the ASMB9 iKVM. So now time to get these parts installed. I may as well do it on camera, it's not very exciting, but equally there's not going to be much exciting stuff in this video. Sorry to disappoint. But let's open the machine up and get these parts in. So first of all, we'll stick these SSDs in. They'll need to be done first because they're under that expansion card. So I'll get these installed first. So we'll just take that out. It's also nice to see actually on this, I just realised it does actually take 22110 NVMe or M.2 SSDs. So your normal your normal M.2 drive is 2280, so it's 80mm long, and obviously you get the smaller ones. But for some servers, you can get ones that are 22110 long, so they're 110 long. They're a lot longer. Those are generally going to be higher end ones. They'll have things like weird sort of cache type sort of capacitors to save the cache and the amount of power loss, things like that. Much larger, higher end drives. And you can actually get them quite cheaply nowadays because they're often like random X enterprise gear that isn't really usable on a standard desktop. So it's nice to see that this board can actually take full size or full huge length 110mm long SSDs. So that's really good. The screws come out with the standoff, so I'll get that out off camera and then we'll get these SSDs in. Okay, so time to get the SSDs in, which I've taken out the box here. And I think this video is literally, everything in this video is ridiculously packaged apart from that network card. Because I've taken the SSDs out of the box and now they're in these little metal tins. I mean, fair enough, give people a nice experience, but this does seem a bit of a complete waste of packaging and stuff from an environmental perspective, because I've got sort of like metal tin for my SSD, which is in there with a manual, because of course I need a manual to put this in, then a bit of foam, and then the SSD, and then more foam. I mean, fair enough, it's a nice experience, but yeah, this does seem a bit of a waste of packaging. I know I'm moaning, but, you know, I like just getting like random OEM parts in a bag that just can go straight in the machine. But there's the two SSDs. Seem pretty nice, and yet these are fairly high-end, decent SSDs with a DRAM cache, and that's kind of what I wanted. I know DRAMless SSDs are getting better nowadays, but I'd rather just stick to DRAM-based SSDs for the relatively limited cost or limited additional cost. I mean, these were £40 to £50 each for a terabyte each. That's not too bad. So let's get these in. And then we can get that network card in. So that can go in there like that. That one can go in there like that. And then we'll just get these screwed in. And we get the rest of the parts in. Be interesting to see how fast this machine performs, because this should be pretty quick. So like, it's a really pretty modern machine. And then we've got a pair of NVMe drives for storage. It's going to be a pretty nice quick machine. Okay, so that's the SSDs in there. And I've also just noticed that with this fan being here, this will actually actively cool the SSDs. So that'll be nice. I mean, they won't get too hot, but they aren't, you know, they will be reasonably hot running SSDs. So it'll be nice to actually have that active cooling there. So that'll be good. So let's get this network card in. Now, I think to do this, I'll just need to lift this backplate thing out, then screw the network card onto this, and then that'll go in. So get that out there. There's a screw on here for the back retention clip. I don't know why I'm filming all this, because this is probably the most boring thing I could be filming right now, but equally, let's face it, my other content isn't exactly exciting either. So, you know, if people want to watch that, well, they'll probably want to watch this. So let's get this network card in. So that can go in there like that, just like that there. Easy enough to do. And then we'll screw this in through the top. So there we go. That's the card now installed in that sort of rear retention bracket. So what we'll now do is we'll get this installed in the machine. So I think what I'm going to do is I'm going to take the riser card out first. It's not actually fixed into the slot or anything. It should just pull out. And then we'll just put that onto the card like that there. Just like that. And now this whole assembly should just drop down into the machine like so. So that'll drop in there. That'll go into the slot. Yep, that's all in there perfectly fine. And then we can just put a single screw into the back. And that'll be the network card installed. And then what I'll quickly do is I'll adjust that fan deflection shroud thing to direct here over the card. It probably will make basically no difference, but I have it, I may as well use it. So this thing here is like a sort of slot, it's just plastic, but there's a slotted piece here with this screw. So in theory, if I loosen that screw off, I should be able to slide it over a bit and tighten that up again. And it's not made a huge difference, but that's just moved in a little bit. So what hopefully that'll do is it'll allow the air to kind of be pushed a bit more over the card. You can have less air coming up here and missing it. So that should hopefully help keep the SSD in that network card fairly cool. So yep, that's all done there. Final thing we need to do is put this management controller in, and that will just literally go onto this header here. It should literally just push on like that. It is keyed, so it should be fairly easy to get accurate, but I'll just make sure I don't get it completely wrong. That'll go on there like that. And that's now the KVM installed. So yeah, that's all the work done on the hardware. Time to get the top back on and get Proxmox installed. Okay, so now we're ready to install Proxmox. So I'll install it using this, which is a Xalman VE300. I don't know if they still make this or another company makes it now. Essentially, it's an external hard drive, but it can emulate an optical drive from ISOs stored on this. Normally I use Ventoy for this kind of thing, where you can basically format a flash drive running Ventoy and it'll boot it. You can just stick ISOs on this and boot from them. But for some reason that doesn't work with Proxmox. I've tried it on a bunch of different machines historically. It just doesn't seem to work with Ventoy. Whereas because this emulates an optical drive, it will. So boot this up here. And we'll pick the Proxmox ISO that's already on this and get Proxmox installed. Cool, there we go. I've picked Proxmox VE on that. And now if I press F8 on this to get into the boot selection menu. Also interesting here, detected 88 device Intel SSD, but those are Sabrent SSDs, that's weird. Ignore me, I'm being a complete idiot, it's an Intel SSD that's in this, of course it is. Completely, I was like, that threw me, yeah, this has an Intel SSD in it, that explains it. Cool, so there we are, so now we can pick the Zalman Virtual CD-ROM. So, the way it shows up here is it shows up either as a external hard drive, or as a optical drive. So we want to boot up as the optical drive, although I think it's only showing optical drive. Anyway, we're going to boot from the optical drive there, so that'll do. And that will now start up from the Proxmox ISO. And because it's essentially emulating a CD, it should be much more compatible than using Ventoy. So let's boot up into that and get this installed on. It's also worth mentioning with this, because I'm booting from NVMe SSDs, this will have to be set up in UEFI mode. Generally speaking with servers, quite often they'll still use BIOS mode, or lots of servers by default will still use BIOS mode, but because I'm booting from NVMe, it'll need to be in EFI mode. So here we're on the Proxmox installer, so let's run through and hopefully those new drives will all be detected. So there we go, we've got NVMe N1 and N2, yep, both drives are detected there, that's good. So what I'm going to try and do is set these up as a mirrored ZFS pair, so that's going to be ZFS RAID 1. I'm going to say I want to use NVMe, both of those. I don't want to use my external drive as well, so we've got a pair of 1TB drives, the NVMe drives, using ZFS, and it's essentially a RAID 1, so it's a ZFS mirror. That should do absolutely fine. Default settings should be completely fine there. So we press OK. That should hopefully set me up with a mirrored pair of SSDs running ZFS. So that's all set up there. So now I'll quickly go through the rest of the setup wizard and then we'll come back. Okay, so now booted up into Proxmox as you can see. So resistant login prompt. And as you can see, the network link's come up and it's come up at 10 gigabits. So that's working completely fine. I can also see by the light on the switch that it is a 10 gig link. So that's working brilliantly. If you take a look at laptop, as we can see, we're now in the Proxmox web interface. So it's all working absolutely fine. We can see we're in here. Everything's set up, that's server. You see we've got the 8 CPUs, or 4 core with hyperthreading, 16 gigs of RAM, and the terabyte of NVMe storage. So yeah, that's up and running. So a few more things I want to now do to set this up. Obviously I need to get things like the BMC controller set up. I also want to enable fan control to get this thing quieter, because that is very annoying, and I'll need to tune the fan curves. And once we've got it all working, we'll go and get it in the rack. Okay, so I'll do most of the config off camera, but what I thought I'd quickly do is just demonstrate the PWM config setup. So I've installed PWM config and LM sensors from the apt repositories, so we can now set all this up. So the first thing we want to run is sensors detect, and it'll detect all the sensors in the machine, which will be like the fan controllers and temperature sensors and stuff like that. So run like that, and it'll say, do you want to scan for them? Yes. Let's find a bunch of them there. Some Super IO chips. Yes, I'm just going to scan for everything I could possibly need to scan for. Yes. And do I want to scan for ISA? No, because I'm not getting anything ISA in a machine this age. I2C, yeah, may as well. I'm just going to go through all the defaults. And there we go. So that's now found a bunch of sensors. Don't scan it. Yes, I'm just going to do all the defaults here. So let's go through all this. Cool, so that's us done there. So say yes, that's found all the sensors and all the different things. That should all be fine. Don't want to add the modules. Yes. That's all the kernel modules. Put that in there. And then we should be good to go. So I can either reload all the kernel modules or restart the machine, but let's do that. And then set up PWM config. So I've now restarted the machine, so that's loaded the appropriate kernel modules. So now we can run PWM config, which is part of the fan control package. And this is now set up the fan control, so it's set to everything there. So this is now telling me that the fan output is currently set up for automatic control, but do I want to switch to manual mode so this package can take over? I do actually want to do that because the automatic mode is just far too loud, so we'll say yes. Yes, we'll say yes to all these. This will run for each fan. You can see all the fans are running at speed 76. And the fans are all now reaching full speed. I don't know if you can hear me. Hopefully my microphone's not completely drowned out. This is very loud. In fact, we're reaching about 80 decibels. This thing absolutely screams when the fans are running at full speed. But that's fine. What fan control is going to do right now is it's going to want to calibrate itself. So it's running my fans at full speed. Then when I press enter, it'll now stop all the fans one by one. And it basically tries to work out what speeds each fan will start and stop spinning at. So that's saying, did I hear a fan stop? No, so I didn't hear a fan stop. So what it's now doing is for each fan, it's adjusting it, it's giving it different PWM values for the speed and measuring the speed that the fan is running at. And this just lets the software build up a fan curve. So I'll go away off camera and let this finish because this is currently deafening, and we'll come back once it's done. Okay, so I've now finished setting up the fan control. I did that off camera, I'll show you the config file in a second, but the machine's now running it, and if we take a look at the meter, it's going to be a lot quieter. So we're sitting around about 50 decibels, which compared to earlier at full speed is a lot quieter. And it is, even though I've not got a measurement for it when it was on its original sort of default auto speed, this is a lot quieter than that, I can definitely tell. Now, I'll need to do a lot of fan tuning, just try and get the fan curves quite exactly how I want them. But as you can see here, we're currently sitting around about 36 degrees at idle, which is absolutely fine. I'd rather this ran a little bit hot, but ran quietly, rather than having it, run really, really cool, but with all the fans blaring really, really loudly. But this is set up that in the event that if the machine does need a lot of CPU power, the fans will still ramp up. So for example, if I run the stress command, which will dispatch 8 stress threads, which will stress the CPU, and then we'll take a look at the noise level on the sound meter, and you'll see that the fans will still ramp up. So as you can see there, we got up to about 60 decibels. Now, it would also go even higher. I'll just stop that running. But what it's basically doing is fan controls looking at the CPU temperature every 10 seconds and adjusting the fan appropriately based on a kind of curve between two set points. So it works like a standard fan curve, but because it's done in software now, it's easy to configure and it gets around that weird BIOS that doesn't really have good fan control. So if you want to take a look at the settings for this, just very, very quickly, you can see it here. It's pretty simple. I'm not going to go into too much detail, but as you can see here, we basically specify which sensors we're using. And then for each fan, so there's 3 different fans, we set a minimum temperature that the fans to run at, a minimum temperature at which the fan will run at the slowest speed possible if the CPU temperature is below that temperature. Set that to 45 degrees. You set another temperature, which is the maximum temperature, which is set to 90 degrees. If the CPU is above 90 degrees, the fan should be running at the absolute maximum speed possible, and it kind of figures out a curve in between those. And down here we've got setting about the minimum maximum speed it'll reach, and I've set it so it'll run at a minimum speed of 50. That's kind of the PWM value, not obviously an RPM value, and I found that 50 is kind of the best to keep it consistently under 45 degrees at idle, but it means that if it does need to ramp up, it will. If I set that even lower, it will run even quieter, but then the slightest bit of CPU load will cause it to start heating up quite quickly and the fans will ramp up. And I would rather have the machine a little bit louder, but consistently at that volume, rather than basically silent, but then frequently having to ramp up and down, because that frequent ramping up and down is what you notice. You notice that much more than the constant noise. And ultimately this will be installed in a rack that I have added a lot of soundproofing to, and I made a video about that, so that'll get the noise away as well. So there's probably a little bit more tuning I need to do with this. I need to actually test it when it's actually running production workloads, see what the CPU load's like, maybe tweak it, maybe make it a bit louder, make it a bit quieter. I'll need to play about with it. But what we'll do now is this is obviously a lot more manageable. So what we can now do is get this installed in the rack, get it set up and working, and I can always tweak this as I go on, because this is easy enough to configure over time. So the next thing to do is take a look at how we'll be rack mounting this. Okay, so it's now time to get this in the rack. So let's quickly talk about how we're going to mount this. Now with this server, I probably could mount it without rails. It's shallow enough that I think it would be okay, but it's kind of getting to the point that you'd start to want rails. Any deeper than this, you'd want rack rails. And my current server, my main NAS, is already on rails, and I actually really like it. It makes it really easy to get in and out the rack for maintenance. So I wanted to put this on rails as well. And it did include some rails, however they were too deep for my rack. My rack's only 600mm deep, and the actual posts in the rack are even closer together than that, so the original rails that came with the server wouldn't work. So instead I've picked up these, which are kind of like generic rails, so they're more of a shelf than anything, so this will kind of mount into the rack, and then the server will kind of just sit on this piece here, and they're kind of adjustable, so they have these other back pieces here, so you screw these on at the back, and get whatever sort of length you need to get it properly mounted in the rack. So hopefully this will work okay. The only thing I've noticed is these only have 2 screw holes in the front, whereas the server has 3, so to try and fix the server into the rack so it doesn't pull forward might be a bit tricky. I think I'll just basically screw one of these in on each side onto the rails, and then for the server, I'll put the server and then screw through the server and these rails to get the other screw in. So I'll figure all that out off camera, and then we'll come back. But first of all, let's take a look at the rack as it is now, talk about how we're going to rearrange it to fit this in, and then we'll get the server installed. Okay, so here I have my rack in my office, and this is where we'll be installing this. If people are wondering what rack this is, because everyone comments every time they see it, it's a ZPAS SJB, so ZPAS SJB, but it's not really widely available for retail sale anymore. When I bought it, I could just buy it on eBay and it just turned up. But nowadays they seem to be a bit more special order, so I don't know if you'll be able to get one. I've previously installed soundproofing material into this rack just to try and quieten it down, and that was really effective, so definitely check that video out. So in here we have my existing NAS on the top, that's that 2U machine. Then we have this shelf, and that's a 2U shelf, and it just holds old hard drives, and it's just basically accumulating junk. None of those drives I need, they're just all really old hard drives just sitting around. So what I'll do is I'll take that shelf out, I'll put a 1U shelf in just because I may as well keep a shelf in there, and then I'll install the shelf, or the new server, directly below that NAS there, and that should be fine. I'll find another place for those hard drives, or just get rid of them, they're all pretty old. So yeah, all I'll do is take that shelf out, put the server in under my NAS, and then put a little 1U shelf and just fill the space. So yeah, time to go and do that. Okay, so I've taken that 2U rack shelf out and put a little 1U shelf in, that's absolutely fine to hold everything. And then I've now put the rails in, so you can just about to see those new rails sitting there and there. And what I've done for these rails is I've screwed it in with 2 screws at the back of the rack, but at the front of the rack, I've only put the top screw in on each side, and I've just left a cage nut in the bottom screw hole. So what that means, when I put the server in, I can put the bottom screw through the front of the server and through the rail. So the rail will be fixed in at the bottom, but the server will also be fixed in at the bottom. It just means that the server won't pull out. So if you've say got a cable plugged into the front of the server and you go to pull it out, you don't end up pulling the server forward as well. The server will be screwed in. So yeah, that should be fine. And then finally, I've prepared some cables. So I've got a power cable, a network cable for the main network, and a network cable for the management controller as well, sitting there, labelled up so I know what they're for. So I'll get these 3 cables in, get the server installed, and then we can fire it up. And there we go, that's the new server now installed. As you can see, it's installed there, and I've now put a bottom screw in at each side, so that's perfectly secure. So what we'll now do is we'll fire it up, should probably get very, very loud, and then hopefully once the OS boots fan control will kick in, it'll quieten down. And then once that's all set, all booted up, what I'll do is I'll go away, set it up, get some stuff moved on to it, get things set up, and then we'll come back and take a very quick look at the software setup. But I'm not going to go into that too much detail in this video. So, yep, time to fire this up and check it all works. There we go. So it's now running there. So let's let that boot up. And I always forget how good that soundproofing in this rack works. Like, it's so much louder when it's out on the bench. Putting it in there, even with the standard fan control, it's not actually that loud. It's still too loud to really have in this room without the fan control, but that isn't too bad. That soundproofing works so well. But yep, just time to go away, let this boot up, and then we'll come back when it's all working. And there we go, that server now powered up and working. And it is super quiet. Realistically, the rack doesn't sound really any different to how it did before, so noise-wise it's absolutely fine. But this does really go to show how good that soundproofing I put in is, because if I open the cabinet, you can definitely hear that server quite a bit more noticeably, but with the cabinet door shut, it's basically inaudible, which is brilliant. So what I'll do, I'll take a very quick look over on the screen, just take a quick look at the setup, demonstrate my Proxmox install. I've not got much set up on this yet, obviously I've just literally installed it. We'll take a quick look at the Proxmox web interface, quick look at the management interface, and then we'll wrap this up. Okay, so let's do a very quick look at the software setup. Really not going to go into too much detail here. However, some people have already expressed interest that they want to see kind of more of a soft review of my home automation setup, my home server setup, so I might do that at some point in the future. I just kind of want to get it into a better state, because currently it's a bit bodgy and there's a lot of things that aren't quite right, so I kind of want to tidy it all up, get it all presentable, and then I'll do a dedicated video on that. But as you can see, here we have Proxmox, all the hardware is detected, all the RAM is detected, so 16 gig. It's all working here absolutely fine. We've got going in here, we can see the local storage, we can see we have the full terabyte of storage here, so that's working completely fine. And I've set up a few different VMs. I've got a lot more stuff to put onto this and a lot of stuff to finish migrating over. This isn't fully set up yet, but I've got one container for Netbox, which is kind of like web-based server network documentation stuff, so IP address management, server management, that kind of stuff. It's going to be really useful to keep track of IP addresses that I'm currently keeping track of in a spreadsheet, which just isn't very neat. The next service we have here is Bookstack, which is kind of like an open source version of something like Confluence. So it's like wiki-based pages you can easily edit and display in a browser. And I'm using this for documentation. Over the years, I've kind of just had everything documented in my head, thinking, when I set something up, right, I'll remember how this works, and I come back about a year later and have no idea what I've done and can't figure it out, and it just is a complete pain. So I'm going to try and start using this to document my home automation setup and server configuration, just to make things a bit easier for me in the future. Finally, here I have Home Assistant set up, and this is my plan to migrate all my existing Home Assistant setup from my current server, where it's all running in Docker, into a VM here running Home Assistant OS. My current home automation system was initially built around Node-RED, and I didn't even use Home Assistant, it was just purely Node-RED. And then I kind of tacked Home Assistant onto that, but it's all running under Docker, which made sense for Node-RED. But now I'm running Home Assistant, that doesn't really work well under Docker because of the way Docker handles the network. You've got a sort of layer of NAT in there, and it breaks a lot of the auto-discovery stuff that Home Assistant does. So what I've now done is I've set up a VM here running Home Assistant OS, which is more designed for running Home Assistant, and I'll run Node-RED and all the other utilities inside that. Currently this is a bare install and I need to actually set it all up, but the plan will be to migrate from my current setup into this to get Home Assistant, get Node-RED, potentially Grafana and InfluxDB also migrated into this, and run my entire home automation system inside this VM running Home Assistant OS. This should make stuff a lot easier. So I'll get all this set up as well, and I'll probably do a future video on that, but yeah, that's running on there, ready for me to move everything over. So that's the main sort of setup there. Not going to go into too much detail now, it's Proxmox. There's better videos on Proxmox, but I might do a video on the setup in more detail in the future. The final thing I want to look at is the IPMI interface, which we have here. So I've pulled this up. It's absolutely fine. It's a fairly standard iKVM. It's based around the AMI Mega Rack, so you see the same interface on a lot of different sort of white box and regular sort of purchasable motherboard type servers. It's pretty standard. You can come in here, you've got all your sensor readings, various information on parts of the machine. It's pretty basic. A lot of the functionality doesn't seem to be fully implemented. Like I think the FRU information just kind of shows blank things, but it does work. The main thing is it's got remote KVM console, which is also thankfully an HTML5 console. I don't need to rely on a Java applet. That comes up there. We have a remote KVM console. It has full virtual media support, so I can pass virtual media in if I want to, which is quite nice to have. So there's your image redirection there. And power control, so I can easily remotely reboot the server and stuff. It's basically everything I would need, so that's absolutely fine. So yeah, that's the software setup. Very quick whip round of it. Didn't really want to go into too much detail right now, and I'll probably do a dedicated video on this in the future. But yeah, hopefully you found this interesting. So there you go. That's a look at my new home Proxmox server. And I'm very happy with it. I definitely got a really good deal on this machine. Wasn't actually planning on buying a server, but when I saw this, I just kind of picked it up because it was so cheap. But I'm very happy with how well it works. The fan control on it is a bit of a pain. I was definitely hoping it would be a bit easier, but being able to set up with fan control under Linux is absolutely fine. It just means that with this server, any operating system I install on it has to be able to allow me to install the fan control package. So things like Proxmox, just Linux-based OSs are generally going to be fine, but I maybe wouldn't want to be using things like VMware, or maybe things like XCPNG that while they are Linux-based tend to break installed Linux packages when you update the OS. Thankfully Proxmox is generally okay with that, so I can just install fan control and the fans will work absolutely fine. So yeah, pretty happy with it. So there you go, hopefully you found this interesting. Definitely quite good finally building an actual dedicated VM host for home rather than just kind of shoving VMs onto my NAS. And I'm really looking forward to seeing what additional stuff I'll be able to host on this, because I've kind of not really been hosting much at home for the last few years, running Home Assistant and Node-RED for my home automation, and that's really it. But I'll be interested to try and install a lot more services and actually start running more stuff from home. So yeah, looking forward to that, and stay tuned for future videos on this. But for now, all that's left to say is thank you very much for watching.